Reading an architect scale in the Imperial system uses fractions, and that is fractions of an inch. You can see these fractions printed on the scale ruler, such as 3/4 or 1.5, 3/8 of an inch, 1/8 of an inch, half of an inch, 3/32 of an inch. But there are also whole numbers on it, such as 3 or 16, and there are other combinations as well. So I'm going to make sense out of these numbers, and I'm going to make sense out of the numbers along the edge of the ruler, and then we'll do some practice readings on some of this stuff. So first things first, the numbers in the corner, 3/4 of an inch. The idea is that 3/4 of an inch, and that's how inches are standard notation for inches. Two of those whiskers, you can call those primes, but remember, primes are numbers such as 2, 3, 5, 7, 11. Those are prime numbers. So just tick marks, check marks, whiskers, whatever you like. That's standard notation for inches, and the idea is that 3/4 of an inch equals 1 foot. That's not 1 minus 0, that's 1 dash 0, and that's 1 foot 0 inches. So along the edge of the ruler there are major divisions, major lines laid out every 3/4 of an inch, and every 3/4 of an inch means a foot. So a foot is about this long, and it's being downscaled to fit the paper, to fit the drawing, to a 3/4 of an inch. So instead of a full size, a 10-foot long hallway would need 10 feet of blueprint and paper. No, it's every foot is now 3/4 of an inch. Okay, and there are numbers laid out on the edge of the ruler every 3/4 of an inches. The edge and the ruler is laid out from both ways. So the 3/4 scale starts from the left and reads towards the right, but there's another scale along the same top edge that starts on the on the right and reads to the left. So I hope you're not dyslexic for this video, or for reading an architect scale. Please don't be dyslexic. Get used to it. Read the numbers and the scales back and forth, left to right and right to left. Also upside down, coming up. Other fractions would be just another example. We looked at, say, 1/8 equals a foot. So that means that there are distances laid out on the edge of the ruler. Every 1/8 of an inch, that's a small little guy, and every 1/8 of an inch represents 1 foot in reality. Okay, so the fraction number, or the first number, these numbers relate to what's on the drawing or blueprint. So that's in the drawing, and the other number, the 1 foot, that's the reality. How do I'm going to write it this way. So those are the numbers in, or that's the life size items. Some of these numbers are not fractions. Some of these numbers are whole numbers, such as 3 or the 16 that we looked at. And the same idea applies. So 3 inches on the edge of the ruler represents 1 foot in reality. Okay, so every 1 foot has been shrunk down to a 3-inch length, and those are the distances there that are laid out. Okay, I hope that makes sense. Now these numbers aren't ratios. They do work out to be ratios, but unlike the architect scale that uses decimals and has ratios printed on it, this one doesn't have ratios. So these numbers aren't the ratios, but they could be used to represent ratios, or to generate ratios. For example, if every foot is now shrunk down to be an inch. That means downscaling by a factor of 12, because there are 12 inches in a foot. So on the next slide, if 1 inch represents 1 foot, that means that everything is downscaled by a factor of 12. Whatever is 1 unit in the blueprint, it's 12 units of the same in real life. 1 inch, 12 inches. So that's the ratio for it, and that's how it would be written down. Or if you have 6 inches, that represents a foot, it's been downscaled by a factor of 2. It's a 1:2 ratio, where you see the 3 on the edge or at the corner of the ruler. That means that it's a 1:4 ratio, because there are 4 3-inch chunks in a foot. So when you use the 3-inch scale, you downscale everything by a factor of 4. It's a 1:4 ratio. The rest of the numbers work the same way. The 1.5 means that it's a 1:8 ratio. The 3/4 inch scale means that it's a 1:16 ratio, or the 3/8 scale means that it's a 1:32 ratio, because if you divide 12 into 3-inch chunks, you get 4. If you divide 12 by 1.5, you're gonna get 8. If you divide 12 by 0.75, you will get 60. So that's how these numbers come about. They are close to, but not identical, to the metric architect scales, because on the metric one, the numbers are 20 and 25. They're around multiples of 5 or 10, not numbers like these. Okay, let's take a look at the edge of the ruler. This one reads from the right to the left, and like I said, you have to get used to it. And to lay out a 7-inch long line, that would require you to start drawing a line from there and then find your numbers on the scale that's given. Say that would be 3 inches, 6 inches, 9 inches, and it doesn't say so, but that's 12 inches. So this is your foot. Along every edge you will see a finely graduated part and a different one. It's a different one. So that's the next slide. So let's work with this one. What you do to lay out a 7-inch long line, what you do is you start at 0 practically, and you need to locate your numbers. So if 3 is there, this is 1 inch, 2 inch, 3, 4, 5, 6, and that would be 7. 7 lives there, so you need to extend a nice straight line. Sorry, I can't do straight line here and make it this long, because that's where the 7th inch lives. Another one would be, say if you don't want 7-inch lines, let's see what number lives there, what fraction can be located there. I know it's kind of small in your field of view, and I can't really zoom into it as it is set up. So you can see that between 6 and 7 you've got 1, 2, 3 lines, so that's going to be 4 gaps or 4 distances. So between 6 and 7, that's 4 jumps, so every mark is a 1/4 inch. 6 inches, 6 1/4, 6 1/2, 6 3/4, 7 inches. Okay, so that's the idea that works along this scale. This is the 3 inches equals a foot scale. And along the rest of the scale, what you see is, so there is the finely graduated end of it, and then you have, here this is 1 foot, 2 feet, and the 3rd one, and there's a 4th one. The 20, the 18, and the 16 doesn't belong to this scale. That's why the numbers are offset vertically. These are the numbers that are on one line. Sorry, it's a little wiggly, my bad. I have to walk while I'm pulling a straight line, so it's a little limited. sorry, but you get the idea. With the 3-inch scale, and it's 0. You know, the 1, the 2, and the 3 are on the same level, so those belong together. Forget the 16, the 18, and the 20, especially that they start from that they are increasing in this direction because they belong to another scale which reads from the right to the left. Alright, so don't get lost on this one. I know it's not easy. I didn't say anything about being easy. Next scale is a 1/2-inch scale. Let's quickly make sense of this one. On a 1/2-inch scale, those are the gradations or line work that you see, and the full foot is always laid out for you. So you might as well write 12 there because the 12th inch will be there. If the 12th inch is there, the 6th inch is there. And if you want to draw a 7-inch line, you would need to start at the 0 there and find your numbers in between. So that's 3, 6, that must be 9. That's 7 is there. So you draw a line exactly that long. That's a little too long, but exactly that long because that lines up with the 7th inch line. Yeah, it's straining your eyes and everything, but that's where these lines are, and that's how they work. And between 6 and 7, there's only one line in between, one line that makes 2 divisions, so that's 6, 6.5 inches, 7, 7.5 inches, 8, 8.5 inches, 9. That's how the scale works. That half, again, doesn't mean that those smaller minor hairlines are 1/2 an inch. It just happens to be a coincidence that they are so. On the 1/2-inch side of things, you see this, you see numbers because the 1/2 inch is indicated there and it reads from the right to the left. You're using the numbers that read from the right to the left. So 10, 9, and 8 is out of the question because they don't read from the right to the left. You're going to be using 2 and 4, and this will be 1, 3, and 5. So, if you want to lay out a 3-foot long line, you start at the 0, 1 foot, 2 feet, 3 feet. And if you want to make it 3 feet, 2 inches, then you have to go just a little bit over here that you can, you really can't see it from this angle. I know, but you just go back to the previous slide. Let's look at another one. Here is the 3-inch scale that we looked at before briefly, and this one has a lot of detail in it. You can see that it starts reading at its 0 is somewhere over there, so the numbers go 3, 6, 9, and here is your 12. And if that's 9, that's 10, that must be 11. If that's 9, that's 9.5 inches there. If that line is 1/2 an inch, this line here must be an a quarter, 9 1/4, 9.5, 9 3/4, 10 inches. And so every small line is going to be 1/8 of an inch. 1/2 of a quarter is an 8. So if you want to lay out a line that is exactly 6 3/8 of an inch long, you have to make it, from the 0 all the way out to, there's 6 inches, and 3/8 would be, that's 1/8, 2/8, 3/8, exactly that long, because that's how the scale works for this this scale, where 3 inches mean a foot. So that's how the numbers work out. The 1.5-inch scale looks like this. Same idea. If you want to draw a 7-inch line, you have to find 7 on it first. That would be between 6 and 9, but it reads in this direction. So there is 7, that must be 8, there is 12. So to draw a 7-inch line, you just go to the 7, just like so. And between 6 and 7, that's gonna be 6.5 here, and that's got to be 6.25, 6.5, 6.75, 7. You get the idea. This one has a pattern to it. Okay, let's look at something microscopic. On the 3/16th scale, it's just the 6 is missing from this corner here. It's 3/16 equals a foot. This is your whole foot, and that's a toothpick. So the width of the toothpick would be, let me see, that's 6 inches. That must be 3 inches there. That's just 1, 2, 3 inches. So the width of the toothpick as is 1, 2, 3, 4, 5 inches there. 5 inches on this scale. And the last one, the smallest scale, 3/32 of an inch. And 3/32 scale means that everything is downscaled by a factor of 128. So that means there's your whole foot, there's your 12 inches. That's got to be 6 inches there, and the edge of the pencil lines up with that hairline there. We don't have too many lines, so that's 2, 4, 6, 8, 10, 12. So that's going to be 8 inches. The width of the same toothpick is 8 inches. Now, I know it's an eye strain, and I try to record it in a good enough resolution with a steady image. So, I hope this makes a little more sense out of reading an architect scale in fractions. Just like with everything, get used to training your eyes and working with your mind, and get going with it and practice.